Lesson 100, why don't we start with some review? There was a little confusion about some of these triangle problems. They could use just a little extra work. How we label angles. Taking a look at the triangle on the left, first of all, what type of triangle? Does that help? 90-degree angle means it's a right triangle. Let's label the top angle. 3 possible labels. Just angle B, angle ABC, or angle CBA. You can go from here, here to here, here, here to here, but this needs to stay in the middle, right? Or by itself. Over here we have another triangle, not a right triangle. All the angles are acute or obtuse. Acute, they are all under 90 degrees, right? Under 90 degrees. Let's label the top angle. We could call it just M. We could call it ZMO, or even call it OMZ. Why not? Quiz question. Can it not be angle Maz? Because the vertex label needs to stay in the middle or by itself. Another way to label angles is to make this little arc and say, well, this is angle D. That's another way people have done it. I feel it comes in handy when you start doing supplementary or complementary angles. We can draw this arc and say red is 180 degrees, D is 180 degrees. But we can also label this angle green, call it F. Is it obtuse or acute? Obtuse. And the blue, let's call X obtuse or acute? Acute. That's easier to do with arcs. Same over here, you know. Blue is an angle, green is an angle. Green and blue are complementary to each other to add up to 90 degrees. The 90-degree angle is the dashed pink line. Okay, moving right along. Lesson 100. Woo! There it is. Congratulations on getting to lesson 100. We're talking advanced ratio problems. What does it mean for a ratio problem to be advanced? Well, we got a ratio of nuts to bolts, 11 to 2. 260 nuts and bolts in a pile. How many were bolts? How is that any more difficult than the ones we've done before? Well, if this was the ratio problems we've grown accustomed to, we'd say nuts to bolts. That's my ratio. It shall not change. What's the ratio? 11 over 2. Or you could show it as 11 to 2. 260 to what I don't know. Which one matches up to what? Does 260 match up with nuts? No, it's nuts and bolts. 260 with bolts? No, it's nuts and bolts. Uh-oh. This is a total. And then it wants us to know how many were bolts. I don't know. What do I do? We know nuts, we know bolts, but guess what? We know a total too. How did I find out what's the ratio total? Obviously, we got 11 nuts, we got 2 bolts. In all, at the most reduced rate, we have 13 for a total. So there's actually 3 ratios implied now by adding on the total. Since I don't have a finger like the book, I have to use this strange deformed hand. Let's have it cover up nuts. What's my ratio that's implied? 2 over 13, which is bolts over ratio total. How about cover up the bolts? Now I have 11 to 13. Keep the order the way they are. Keep the top where it is and the bottom where it is. Nuts to ratio total, which is 11 over 13. Finally, and you get the picture, what's the last one that we have not implied? The original one. Cover up the total and we're back to where we were. How does this help us solve? Let's clear out some of the things we did. Which ratio is the one we're going to want to solve this problem? Whoa. Fix what I did. Let's just go from there. Well, what are we going to end up looking for in the end? How many bolts? If we're looking for bolts, that means we need the total, but we hardly need the amount of nuts. So bolts to total is 2 to 13. I know that there are 260 for my total, but I'm looking for the number of bolts. How do I solve a ratio? Cross multiply. What do I have underneath then? 13b equaling 260 times 2, which is 520. Let me double check. It doesn't show it in the book, but I trust it. How do I solve for b? This is implied as a multiplication. Undo it through its inverse operation of division. 520 divided by 30 is, yikes, 40 bolts. If that was too fast, let's go a little slower. One more time. The ratio of underclassmen to upperclassmen was 2 to 17. If 3,800 students attend the high school, it must be a public high school, how many were big kids, older kids? What are the ratios implied? Obviously, 2 to 17 is underclassmen, upperclassmen. That's not new. What's the third number we know that we haven't talked about until today? Lesson 100 tells us there is a total. And what is that most reduced total? Add your two components to the reduced ratio. 2 and 17 gives us 19 for the total. Now, what are these subscript and variable type things going on here? I used Y because U and U don't really help me. So younger students is what the S is. Upperclassmen, older students, and then total students, 19. Right? Grab our deformed hand, and what ratio do we want? Because we could have 7 to 19, 2 to 19, or the old 2 to 17 we're used to. I'm guessing it's not 2 to 17 because that's nothing new, and then we didn't even need to do this. So we're going to be keeping the total. So am I covering up older or am I covering up younger? Cover up the one we don't care about right now. Which one don't we really need? We're learning about upperclassmen. Therefore, younger classmen don't apply. 7 to 19, older students to total. How many older students in the enrollment? We don't know. How many total, including underclassmen? 19. I'm sorry, 3,800. And the ratio over here is 7 to 19. So 7 to 19, older students to 3,800, cross multiply. It's kind of all kittywampus here. Hopefully you can follow me. If I cross multiply, what do I get? Starting with this and this, that's 19 older students equaling 17 times 3,800. Nice giant numbers that are more than they need to be. The book likes to be difficult, doesn't it? Times 3,800. 64,600. But don't worry, we get to divide that, right? Because this is implied multiplication. Undo it through division. Cancel it out. Older students, which is what we're looking for. What's the total? 3,400. Does that make sense? Considering the original problem. For every 2 students that are young, there's 17 that are old. If there's 3,800 complete enrollment students, well, that means I have 400 younger, 3,400 older, right? You have practice A and problem set. Show me the work. Ask me questions.